Good morning, students. Once again, I welcome you to my video lectures on GATE coaching. And today I will solve a problem from 2022 IT Instrumentation Technology paper. And the problem is based on three-phase circuit. I will read the problem. In the balanced three-phase circuit shown, capacitor C is 8.2 microfarad and line to line RMS voltage is 440 volts at 50 hertz. The reading on the wattmeter is dash. So you have to solve the problem for wattmeter reading. And this is the circuit. So this is wattmeter, this is three-phase supply. Now you are supposed to know the basics of wattmeter. As you know that you have studied in first year, first semester or in second semester, wattmeters, dynamometer type wattmeter. So a wattmeter is represented. So here it is in the form of a circle. Now wattmeter is equivalent to this circuit. This is what is called as equivalent circuit of wattmeter. This is called as current coil. This is called as voltage coil. A current coil has least resistance, whereas a voltage coil is highly resistance coil. And on this side we connect source, and on this side we connect load. So what is the wattmeter reading? Wattmeter reading is given by current in the current coil. And the voltage across the voltage coil. It is as good as supply voltage. It is as good as load voltage, because the resistance of the current coil is negligible. Therefore, this voltage is same as this voltage. Therefore, wattmeter reading is equal to I into V. This V is same as this. And cosine of phase difference between V and I. Phase difference between V and I. This is what is called as wattmeter reading. Okay? Wattmeter reading is voltage into current multiplied by cosine of phase difference between V and I. So here in this circuit, so this is current coil current. This is current coil current. Whereas this voltage is voltage coil voltage. Okay, this is voltage coil voltage. And coming to three-phase supply. So line to line voltage is 440 volts at 50 hertz, and the sequence is not given in this problem. Therefore, I will assume the phase sequence as R by B. So assume phase sequence as R by B. You know that sequence means the order in which the phases attains the peak value. Phase sequence is R by B. Therefore, R by YB BR. These are three line voltages. VRY 440 0 volts. VYB 440 volts minus 120 degrees volts. Then VBR is equal to 440 angle minus 240 degrees volts. So these are the three line voltages. Now I will mark VRY here. This is VRY. Now I will show it by an upward arrow. The tip of the arrow corresponds to plus and the bottom of the arrow corresponds to minus. This is VRY. So VRY 400 0 degrees. Next, this is VYB. This VYB is 440 minus 120 degree volts. 120 degree volts. 120 degree volts. Now, having marked the voltages, line voltages here. Now you remember that this is a three-phase, three-wire system. Three-phase, three-wire system. So how many meshes are there? Two meshes. There are two meshes. This is mesh 1, this is mesh 2. Now show mesh currents. So one mesh current I will show it as X. So this X is same as I. X is same as I and this is Y. So two mesh currents are X and Y. Now X is same as I. So X is same as I. Now in one of my previous classes I have explained how to write the KVL equations by inspection method. So by inspection method you write KVL equations. Now I will write KVL equations by inspection method. The inspection method is inspection method. First, total impedance in mesh 1. Total, before writing this matrix, so C value is 8.2 microfarad. So calculate XC. XC equal to 1 over omega C. 1 over. So 50 hertz corresponds to 314. Omega is 314.3 multiplied by 8.2 microfarads, 10 to the power of 6. So this is XC. So XC comes out to be 388 ohms. 388 ohms. So it is a phasor. XC is a phasor. It is represented as minus J 388 or 388 minus 90 degree ohm. 388 or minus J 388 or 388 minus 90 degree ohms. Now you write the first total impedance in mesh 1. Total impedance in mesh 1 is summation of these two. That means minus J 388 plus minus J 388. So that is minus J 776. Next, here also total impedance is summation of these two. That is once again minus J 776. Next, we have to write these two numbers here. Now the impedance common to mesh 1 and mesh 2 is this, and the mesh currents are in opposite directions. Therefore, here minus J 388 minus J 388. Now having written minus J 388 here and here, because this impedance is common to these two meshes, the mesh currents are in opposite direction. Therefore, we have to take with minus sign. So when you take these two with minus sign, then it becomes plus J 388 plus J 388. And here, total voltage in mesh 1. Total voltage in mesh 1 is same as VRY. VRY is 400 0 degrees. 400 0 degrees. Or you write simply 400. You write simply 400. Next, the total voltage in mesh 1 is VYB. VYB is 440 minus 120. 440 minus 120 degrees. Now you have to calculate. We have to calculate X, because y is not required. I am interested in x because x is same as I. So how to find x? X is equal to determinant 400, sorry, not 400, 440, 440. So it is not 400, it is 440. Sorry, and here also I have written this as 400. Please make correction. 440, 440, 440. So 440, 440. Next 440 minus 120. Then J388 minus J776. J776 divided by determinant delta minus J776, J388 minus J776. So while calculating the determinant, so one is in Cartesian form, these two are in Cartesian form, these two are in polar form. So we have to convert these two into polar form. So 388J becomes 90 degrees because J corresponds to 90 degrees. Next, minus J776 becomes 776 minus 90 degrees. Now you have to calculate x. So x comes out to be I am not going through the calculations, minus 0.65 minus 120 degrees, amperes, minus 0.65 angle minus 120 degrees. So how will you locate this in the form of phasor? In the form of phasor, it is represented as so negative angle. So negative angle, that is minus 120 degree, means it is measured in clockwise direction. So in the clockwise direction, measure 120 degrees. This is phase and this is magnitude. Now I am sketching 0.65 angle minus 120 degrees. Now minus of 0.65 angle minus 120 means opposite to this. So this is a phasor which is in antiphase with this. So this is what is called as minus 0.65 angle minus 120 degree. So this angle is 180 degrees. This is 120. Therefore, minus 0.65 angle minus 120 degrees is equivalent to 0.65 60 degrees, because 60 degrees measured in anti-clockwise direction. Therefore, current x, which is same as I is equal to 0.65 angle 60 degrees. Okay, I hope that the student have understood this part. Now wattmeter reading. So wattmeter reading, voltage across the voltage coil is VRY, that is 400 volts. Therefore, wattmeter reading equals VI cos phi. Voltage is 440. Current is 0.65 0.65 and cosine of phase difference. So here it is 0 degrees, whereas here it is 60 degrees. Therefore, cos 60 degrees. Therefore, it comes out to be 143 watts. This is one answer. So, wattmeter reading is 143 watts. Therefore, answer here is 143 watts. So, this is how you have to work out problem on three-phase circuits. So, it is a problem on balanced three-phase, three-wire system. Thank you.